My friends, welcome to Math Board. We begin our series of tutorials on arithmetic. Arithmetic is the science of numbers. Greek word arithmos means number, and arithmetic is about elementary properties and rules of calculations for numbers. Today, we're going to talk about numbers, natural and integer numbers, rational and irrational numbers. We will learn how to write rational form of the number having its decimal form. We will know what is the real number and what is the real line. As I said, arithmetic is a science about elementary properties of the numbers and the rules of calculations. But in mathematics, we also have a very beautiful branch of mathematics called number theory. This is the science about more deep properties of the numbers. So let's begin with numbers. My dear friends, like us and subscribe to see new videos on MathBoard. First of all, the concept of natural number. The set of natural numbers is these curly braces denote the set of. The set of natural numbers is the set of the numbers like 0, 1, 2, 3, and so on. Natural numbers appeared when primitive man was counting maybe his cows and other people, or maybe his wives. He was maybe talking about, I have no wife, I have one wife, two wives, three wives, and so on. So this is the definition of natural numbers. Once again, this symbol means the set of. Natural numbers, the set of the numbers like 0, 1, 2, 3, and so on. The next important set of numbers is called integer numbers. Integer numbers is the set of numbers consisting of the same numbers, natural numbers, 0, 1, 2, 3, and so on. And beside, it also has negative numbers, -2, -3, and so on. This is the definition of integer numbers. Integer numbers. Let's write it. It's natural numbers. It's integer numbers. From definition, it's obvious that any element from the set of natural numbers is inside the set of integer numbers. That is why in arithmetics we write the next. N set of natural numbers is subset of the set of integer numbers. And here this symbol denotes subset, meaning that each element of the set of natural numbers is inside the set of integer numbers. The next much more important example is the set of rational numbers, denoted as Q. Q is the set of numbers of the form P over q, where p is integer number. Here, this symbol denotes, it means element of. So p is an element of set of integer numbers, or p is just integer number, and q is natural number. Once again, set of rational numbers consist of numbers represented as p over q, where p is integer and q is natural. Examples of integer number we can give is, for example, 1 over 2, minus 1 over 2, 3 over 4, minus 3 over 4, and any number, for example, minus, this is also integer, this is also rational number. And as we will learn further, we have also the so-called decimal form of the number. For example, 1 over 2 is equal to 0.5. Minus over 2 is equal to minus 0.5. 3 over 4 is 0.75, and this is minus 0.75. This is called decimal form of the number. We have a result in mathematics. Result. Let's write it. Result. That any rational number has a decimal form of two kinds. The first kind is for example, this is the first example. For example, 1 over 2 is 0.5, and we have one digit after our point. 3 over 4 is 0.75. So we have two digits here. And the result is that any rational number has at the first case has a decimal form where we have finite number of digits in its decimal representation. It can be, for example, 5 divided by 1000. It's 0. Yes. So number of digits is 1, 2, 3. It's finite. This is the first case. And the second case is when the number of digits is infinite, but it has a period. Example 9 over 44. When you calculate this fraction using the calculator, you will have 0.20454545, and so on. And this 45 is the period which is repeating, and it will be repeating forever. This is the second case. This is the result. So once again, any rational number has decimal representation where the number of digits is finite or it's infinite, but it has a period. Let's assume an example.